Our next talk is property data management with PostGIS, PostgreSQL, QGIS, and QField by Victor Idakwo, who will be joining us for Q&A. I'm just going to fire up his video right now. Here we are, property data management. And we'll talk to Victor after the video.
Hello, Crunchy. Thanks for the opportunity for this presentation. I'll be presenting property data management with PostGIS, PostgreSQL, and QGIS and QField. And okay, I am Victor Idakwo, the founder of De-Vicks Geospatial and GIS consultant, as well as an assistant lecturer in urban and regional planning. I've had over 6 years of experience with De-Vicks, and as well as 2 years in the academic field. So, all right, let's. Okay, we'll be discussing on land and property as assets to any economy, PostGIS, PostgreSQL, key features for property management, QGIS features for property management, and mobile field data collection, that is the QField features, then with a little bit of demonstration. So in the course of our project, we have PostGIS and the PostgreSQL database hosted in the cloud-based server, and we have 8 communicating with the QGIS, as well as and the QGIS communicating with having set up a project in the QGIS, and we have 8 synchronized with the QField platform, and the QField send the parcel data, the property data, and the building data to the database, as well as it displaying on the QGIS environment. And in the course of the property management that we are doing, key data sets were established. That we have the parcel, the buildings, and the occupant. The parcel is the extent of the land, the buildings, then the occupants are the building units. So now, we know over the years that land and property are general assets to any economy, and so many countries have generated their wealth from land, and land is a factor for agriculture and also a link with food security. And the security of land tenure is an important foundation for the economy of a nation, which informed the idea of the property management system, as well as land and fees and taxations are often generated from land, and which are source of revenue, and we've seen that being played in Nigeria. So now, the key features of the Postgres and PostGIS key features for property management. And we have the tables with the constraints. We have the users, roles, and privileges. Then the views, taking advantage of table join, and the trigger functions and the trigger, then spatial index and spatial queries, as well as coordinate transformation. These are key features we use in our property management. So now, looking at the constraint, in the course of our property management, we have primary keys and foreign keys, and we have key variables, key fields that were a unifier in all play in the course of our management of the property. And you know that in land administration, we have different agencies that are in the process of land administration, and all these agencies work together to see how the land is properly managed. And in our own case, we have the planning office, the director of planning, we have the surveyor general, we have the surveyors, and we have other key agencies. We have the beaconing, and we have other key agencies like the Office for Quality Control and Data Cleansing, as well as the data coming from the field officers. So we have key feature, which is the parcel ID. The parcel ID serves as a unifier in the course of our property administration, because if you look at the ERD here displayed on the screen, you see that we have the property ID being played in the course of the tables that we have here. So the user roles and privileges in land administration and property administration, the user roles and privileges are key features. They help in establishing users. Like in our own case, we have field data and we have roles. And having established the various roles and the agencies that are involved in the property management, then we have the various users, that is the personnel in various departments in this department, and as well as granting them privileges. So we have privileges that will involve inserting, selecting, and updating, while some have some delete privileges. And also, in the course of saving the QGIS project, we have privileges given to them to be able to view the tables, the layout styles, as well as have the QGIS project being displayed. So we have different roles and privileges, which enables proper management of the property, as well as the free flow and the easy flow in the course of the management of the property. So next is the view and the taking advantage of table join. In the course of our administration, we have view. Like we know, view are not permanent tables. They are imaginary tables that help in displaying certain content that we desire to be seen for certain individuals in the course of the access to our database. So we would want the various agencies to have full access to the tables that we have. So we had to create view tables to enable these various agencies interact in their own unique way to our database. And we have the planning, as you can see, we have the planning view table, which have a parcel ID as the unifier, and we also have the director planning, which is also key in the course of the administration of property, and we have the parcel ID as property ID as the unifier, which is the parcel ID. There we have also the surveying, and we can see the view tables that were displayed for the surveying department, and how we have them we joined using the parcel ID. So trigger functions and trigger are unique aspects in property and land administration, because oftentimes we have different information coming from different departments, and we wouldn't want every department to be putting similar information to their various tables and columns, and we have and in order to meet up time, as well as to have easy flow of information, we needed to create trigger and trigger functions to enable the auto generation and auto sending, updating of various tables and as it goes. And as we can see, we have the field data and the office quality control team, and at some point we have movement or trigger and trigger functions displaying between the data that's collected from the field to the planning department. Also, we have data collected from the field to the director of planning, and also to the survey department, and back and forth. We have different communications from these various departments, and these communications were enabled using the trigger functions, as well as enable at some point, once a table is updated, we have certain fields and certain information sent back to the original table, and to update the field. As you can see, we have the director planning field, and we have the role to be updated, and as well as the information, the insert and the update, as well as the delete from the trigger functions. And I will also emphasize on this in property management as well as administration. Trigger and trigger functions are key features in management of and administration of property. We have different informations coming in, and you need trigger functions to be able to transfer information from various tables, as well as communicate between this table at the back end without having to repeat certain processes on and on again. So also we have coordinate transformations, which we use using the trigger functions. As you know, most base maps and most data, online data, are given in WGS until before. I know at some point we needed to project them, and to avoid redundancies, as well as to avoid confusion in the course of base maps and satellite image display, we used the ST transform option, the function to transform our coordinates from different coordinate systems. Like you know, most base maps and data online are in WGS 19.4 with an XPSG code of 4326, and in Nigeria we have Minadatum Zone 32, which has an XPSG code of 26332. So we needed to have coordinate transformations. We have field data, mobile data collectors from the field, having base maps that use WGS 1984, and we have the database being designed for WGS Minadatum Zone 32. So we had the transformation, coordinate transformation, being displayed. As soon as data is being sent from the field, the coordinates are transformed to different coordinate system and to the home coordinate system that we can use in the course of our administration. So this is key, because they have different coordinate system, different coordinate types coming from different authorities or agencies. So you wouldn't want to be stuck when we have the coordinate system or coordinates in a different system. So the coordinate transformation, which we take use of the ST transform as a key feature in the course of the PostgreSQL and the PostgreSQL features for property management. And we have the key features for QGIS. We have as database connection, we project properties. In the QGIS environment, we have project properties that define certain properties, the coordinate system, and other parameters that will enable your project. And like I displayed previously, we have different agencies communicating with our database, and we needed each agency to have a unique display and to have uniqueness in the course of their display and their interaction with the database. And we were able to achieve that using the project properties, the attribute form, which is key in setting how fields and the attributes are displayed, and how one can interact with view and interact with their database. And key plugins we had used in the course of our land administration as well as the property administration. We have the topological checker, which we used in checking the topology and setting topological rules to avoid overlaps, duplicates, and also to make sure there are no gaps in the course of the operations. And we have the azimuth and distance plugin, which was used to send data that were surveyed from using the survey plan that were surveyed by the surveyors. And we also have layer styles, like displayed previously. The layer styles, each information, each layer, data layer has its own layer style, which was, and we had to grant individuals certain permissions to use our layers. And these are key QGIS features for property administration as well as land administration using the QGIS, and as well as the QField. The QField leverages on the power of the QGIS. The QField is a field connection app for QGIS, and it leverages on the power of the QGIS, and it can be downloaded using the plugin options from the QGIS environment, or can be gotten from the GitHub platform. Then in the course of the QField configurations setup, first it has to be configured. The project needed to be configured, and we also have layer configuration too, and as well as setting up base maps, setting up base map and how they could be displayed before the synchronization of the project with the QField, and as well as setting how these layers are displayed and how the data are sent using the QField platform, as well as, and like I said, the QGIS and the PostgreSQL as well as the PostGIS were hosted in the cloud server, which enabled automatic synchronization with the QGIS, and data were sent directly from the field using high processing GNSS Android platform or mobile platforms, and we are sent directly, and we could see how the PostGIS and PostgreSQL interact with the QGIS and have them displayed automatic on the screen, and having different agencies receiving this in feedback using the trigger functions, and then the administration process continues while the data collection also continues at the same time. So now, like, having set up the database for the properties, and set up the various tables as well as the PostGIS layers and the trigger functions and various constraints, taking advantage of the database connection and using the PostGIS and the login details, the various database. The database for the property administration was logged in and can be accessible. Also, we took advantage of the roles and the privileges, and here it's an environment for the field data collection, as well as for the GIS team for quality control and also monitoring of data entry, as well as property editing, as well as adjustments of the property information. So here is the property administration environment, the QGIS project, and like explained earlier, we have the three major layers used in the course of the property administration: the parcel, the building, and the occupant. And taking advantage of the project properties, the various projects, QGIS projects were set up to show different interface for the different agencies to interact with the database. And we save, different agencies have their own QGIS projects. Here we have the planning units. Like we have the different projects for different units and different offices. Display on my screen here is the planning unit, and the planning unit can view, visualize data from the field, and can only compare the data, the information that is collected from the field, as well as give their own necessary recommendation to compare what the property that we have and the information that we have with the master plan, provisions of the master plan. So the duty of the planner is to compare and evaluate the parcel information and the recommendations or the provisions of the master plans that we have, and other plans, accessibility and other provisions. So as you can see, we have the layers not checked in the green color, the layers checked and yellow color as symbology, and the planner could decide on having compared the information of property. The planner can decide on the layer that we have, and also to give his own approval, and then the layer property changes to yellow, and it interacts with the database, the back-end information that we have, and other agencies like the directors, the surveying department, and the beaconing team tend to have a view of this layer. We have parcel ID of 1038, 1038, 10381, and on the planning unit we have it displayed here as been checked by the planner, but yet to be checked by the director. And as soon as it's checked, it changes to green. And then we have the beaconing unit with duty to add beacons, go and establish beacons to various properties that have been established because of the data collection. And we have the beaconing. Like you can see, we have beacons set up for this property, and yet to be set up here for this property that have been established. Like you can see, this is yet to be displayed here due to the fact that the director hasn't given consent to the display, and I think that should be updating in a short while. So, and this is how the different agencies, and as you can see, the interface and the property display are different. And coming to the QField setup, the QField, we're using the property administration QGIS project. The QField was set up using the property that have been set up, and then the various layers properties, and then using the QField configuration, we set up how different layers, the actions of different layers, as well as the base maps and other advanced settings to enable the QField work in its optimum. And then having done that, the QField project is set up and then be sent to the field officers for the field data collection and property administration to continue in the process. And also we have, having sent the QField project, we have the QField project on the mobile app, and we have different property and collected being displayed. And then at the top we have the catalog of different layers, as well as base maps that have been set up. As you can see, we have the occupant, the building, the parcel, and then the field officer can enumerate those properties by establishing their existing location using the high GNSS receivers that have been enabled for data collection process, as well as starting the digitizing process for that property. Like we can see, we have the crosshair of the GPS crosshair, then you can see the establishment of the extent of the property, and then we can, which enabled the field officer to collect data, and then as soon as this is done, we can feed in. We have the property captured by who it's captured by. Then we have different informations that should be filled in from the field, and then we have the parcel descriptions and other information necessary, or we also have other attachments that will also be provided, and the utilities, facilities, and services that are available on that property, and then after that, the information can be sent to the property. So this is how the information, like its constraints and constraints have been set up to enable certain information to be filled. If not, the information won't be sent, as you can see in the form displayed on the screen. And here we have this in the course of the property administration, and in the course of having the property being managed and administered by the various agencies. So what we are currently working on is to enable fast processing and to enable us achieve maximum utilization of database, as well as fast processing in the course of achieving generation of CFOs, certificate of occupancy. We have currently working on polygon segmentation and automatic azimuth and distance calculation using the functions, the PostGIS functions that we have, and then also to enable us. Currently, we are setting up a team for creating plugins for the QGIS to enable the printing of survey plan automatic from the QGIS environment, as well as utility routing, enable routing for utility facility and services, taking advantage of the PG routing functions in the PostgreSQL and PostGIS environments.
Well, unfortunately, Victor is not with us today to answer questions, but I just want to say it's really cool to see a project that's open source from bottom to top, and the use of things like active database logic in terms of triggers to maintain data integrity as changes are put through. And I really love seeing that kind of mobile data gathering. It's really exciting to see projects that are using the whole open source stack in the wild for real work.